Hi everyone. Today I'm testing out the 11th generation BestArc BTC500XP plasma cutter. BestArc did send me this machine for free for the purpose of reviewing it, but I told them I was only interested in doing an honest review after thoroughly testing it, and that's exactly what I did. First, let's take a look at all the things that come with the machine, starting with this little bag of goodies. Over here we have a wrench that fits all the fasteners on the machine, and the one you're probably going to use most is right here on this end, which fits the electrodes. We do have a couple of extra electrodes and a couple of extra tips, and there are two different tip sizes. Both of these are 0.8 millimeter, while the one that's supplied on the torch is a 0.9, used for heavier gauge stuff, and the smaller gauge is used with the 0.8. It came with a couple of hose clamps because it was supplied with a small section of air hose, as well as a small roll of Teflon tape for any air fittings that you needed to put together. I won't actually be using that because I already have an air hose on my compressor. This is the piece of air hose that they supplied, and it's just a piece of reinforced vinyl tubing. Like I said, I'm not going to be using this because I already have an air hose. If you don't have anything between your compressor and the machine, then by all means use this, put some barb fittings on there, and use the hose clamps that were supplied. Next up we have the ground lead, which all stretched out is about 11 feet or 2.7 meters long. So that gives you a fair amount of room to work with. It's got a quick disconnect for the front of the machine right here. And the only real complaint I have about this is that the ground clamp itself seems to be kind of flimsy. This is some pretty lightweight stamped sheet metal, although the spring is quite stout and it's got a lot of spring, so I don't think we're going to have any problems establishing a good ground. Next up we have the torch itself, which comes in at around 13 feet or 3.3 meters, a little bit longer than the ground, and again that gives you plenty of room to work with for most of your cutting needs. The quick connect for the front of the machine can only be installed one way thanks to this little plastic nub. The torch is relatively lightweight, but still feels solid. It's got a safety over the trigger, so you have to lift that safety before you can push the trigger. You've also got a tip guide that you drag along the material you're cutting, and that sets the cut height. Changing the consumables is very straightforward. Just unscrew this shield here that contains your cut guide, and that also holds in your cutting tip, which just slips in over the electrode. Again, this is the 0.9 millimeter tip for using with heavy work, and the 0.8 millimeter tips that are in the bag are for lighter gauge material. This is your electrode right here, and that's what your electrode wrench is for. There's a couple of flats on either side, and that just screws in, and it's not very long-winded at all. It comes out pretty quickly. And then installation of new electrodes, new consumables I should say, is the reverse of that. Just screw in the electrode, give it a little bit of a snug. I don't think you want to go super tight with it. You don't want to strip out threads or get it jammed in there, especially once you start cutting, because everything will be hot and dirty. So like I said, pretty straightforward. You can have the consumables changed very quickly. The machine also came with these two little pigtails, and these are actually for if you want to hook the machine up to a CNC plasma table. So one of them is to sense the arc voltage, and the other one is for the control signal for turning the arc on and off. I don't have a plasma table, but it might be a future project. We'll see. So I'll have to figure out where to put these, where I'll be able to find them in 17 years when I finally get around to that. Next up we have the machine itself, which as you can tell from the size of my hand is pretty compact. I'd say we have about a foot in this direction, or 300 millimeters. This way it's about 6 inches or 150 millimeters. Height-wise, we're looking at maybe about 10 inches or 250 millimeters. It's got a little carrying handle up here. Weight-wise, I'd say it weighs about the same as my bowling ball, so somewhere in the 15-pound or is that 7 or 8 kilos, probably 7 kilos in weight, and that's just a guess. I'm a horrible judge of weight. The cord on the machine is about 5.5 feet or 1.6 meters long and comes with the NEMA 650 plug, which is a 220 volt 50 amp plug. You can run this machine on 110 using this supplied pigtail right here. Plug your standard cord in there, and then you can plug this into a wall receptacle at 110 volts. You are limited in the amperage you can cut with that. So at 220 volts you can cut with 50 amps, and at 110 you can only cut at 35. Looking at the back of the machine, we have our power switch right here, and these two ports are for those two CNC pigtails that I just showed you. You have your arc voltage and your control signal. Obviously, if you're not using this machine with a CNC plasma table, you won't be using these two ports at all. It came supplied with a Type M air disconnect, which happens to be what I already use in the shop, so I won't be changing that out. But obviously, if you use a different style quick disconnect, you'll need to swap that out. Looking at the front of the machine, we have the receptacle for our ground right here and the one for the torch right down here. And then this is an air regulator that's built into the machine so you can change the cutting pressure. This one, you pull that out, you'll be able to adjust your pressure and then push it back in to lock it in position. On the top of the machine, conveniently hidden by the carrying handle, is a chart that gives you the amperages and airflows necessary for various materials. It's actually got three sections on the chart, so one is for 380 volts, then 220, and then 110 down here at the bottom. Here's a close-up view of a similar chart inside the manual that just doesn't have the 380 volt part. Speaking of the manual, it is quite thin. And of course, the first half of it is all taken up by the safety legalese and charts that show what the various bits and bobs are that come with the machine. That said, the manual is quite decent. It's very easy to read and understand, and there are a ton of pictures, charts, and graphs showing how the machine works and what all the buttons do. Starting on page 9, you've got all the technical data, which shows the max cutting, the duty cycle, the airflow needed, stuff like that. So at max amperage, this is a 60% duty cycle machine, meaning you can cut for 6 minutes out of every 10. The max cutting thickness at 220 is 14 millimeters, 10 millimeters at 110, and that's about 9/16 and 3/8 of an inch, respectively, for the Americans out there. You can get away with a 16 millimeter or 12 millimeter, roughly 5/8 or half inch, for a slightly less quality cut. Subsequent pages have a lot of great information as well, such as that cutting thickness chart that I just put up on screen. This page in particular shows you what all the buttons and lights mean on the home screen and how to set them, what they do, that sort of thing. So that's definitely worth a read. And of course, I'll go over that in the video. There's all sorts of stuff about setting up the machine for cutting. Safety again with PPE. There's actually a real nice troubleshooting section in here that tells you if your cut looks like this, it could be too slow or too fast of a speed, or too low or too high of an amperage, that sort of thing. They talk about cutting direction. It's easier to pull the torch rather than push it. So there's a bunch of stuff in here that's worth a read. Talks about air quality as well. Of course, you're using compressed air to cut with this. So ideally, you want dry air and you want oil-free air. Depending on what you've got, that may not be available, so you might just have to make do with what you've got. I know I do. There's actually a little history of plasma cutting somewhere in there too, which is a nice little read. Overall, it's a decent manual. The torch can only be installed one way thanks to this black plastic tab. So just find where that belongs, push it in, and then thread the locking ring into place. The ground lead is a bit simpler. It has a brass quick connect with a tab on one side, and it's just a matter of pushing it in and giving it a twist to lock it in place. All right, I'm going to go ahead and turn this on. And right now I do not have the air hooked up to the machine, so we should get this error here, E05. That's normally where your amperage would be showing, and without air it's going to give you that error. So now that I've plugged it in, I've got amperage showing on the machine. Let's talk about all the buttons that we have up here. First of all, in the top left we have this button labeled air and cut. Right now the little green chevron arrow is pointing to cut. So it is in cut mode right now, and we're ready to cut metal. When you press this button and go to air, it's going to start purging air out of the torch. And the reason for that is so you can set your air pressure. Let me zoom out a little bit and show you that. Now, this is our pressure regulator, and you can actually set your air pressure, which is shown right here, without pressing that button. However, when you actually pull the trigger on the torch, the air pressure shown right there is going to drop by about 10 psi. So you really want to have air going while you change the air pressure. So press this button, you can hear air coming out of the torch. And now when I set this, you probably saw that drop just a second ago. And now when I set this, it will be the actual cutting airflow pressure. So I turned that off, you can see it jumped up by 8 psi. So that's the only way to get your air pressure actually accurate when you're cutting. Once we go back into cut mode, now we are ready to cut material. The next button down is plate and mesh. So that's basically if you're cutting a solid plate of metal, or if you're cutting something like expanded metal or perforated metal. Obviously with the solid plate, it's not going to have any kind of continuity issues where the continuity drops out as you move off the piece. So when you switch to mesh, it keeps the pilot arc going. I'm not sure if it's the whole time, but it keeps it going for a little bit so that you can bridge the gaps in all that, whatever perforated metal or expanded metal you're cutting. And when I press this, you'll see a little icon appear there that looks like a piece of expanded metal. The button over here that says 2T and 4T has to do with the trigger on the torch. 2T means that the trigger is momentary. When you push it, it stays on as long as you're holding it down. When you let it go, the torch turns off. 4T turns that into a toggle switch. So when you press it, it will stay on until you press it again, which is good for longer cuts. The next button down says PA and PT. The PA stands for pilot arc, which is the amount of time the torch will stay on while it's searching for continuity on a piece of metal. And PT stands for post time, which is the amount of time it will continue to blast air through the torch after your cut is finished. Both of these are adjustable anywhere from 3 to 15 seconds, and you can see the display right down here. So right now it's in post time, which is what the machine defaults to. And like I said, you can go anywhere from 3 seconds up to 15 seconds using this knob right here. When you switch to pilot arc, again, you can change the amount of time. I'll set it to 5. But you want to be quick about it because after just a few seconds of being idle, it'll switch back to post time. Like I said before, this is showing our air pressure, and our amperage is shown right up here. That is the max, actually, 50 amps. You can't go any higher than that. And this is our knob for adjusting it, and it goes down to as low as 15 amps. Depending on what you're cutting, you'll change your amperage and your air pressure to make sure that you get through it and get a reasonably clean cut. There are also several lights that appear in the field on either side of the amperage readout. And the one that's on right now says 220 volts. The machine automatically detects what the voltage is coming into the machine, and it'll light that up. So the one above that would say 110 if you were using that small adapter pigtail. I've already shown you the mesh icon that appears when you switch to mesh mode. And over on this side, you'll have 3 different icons that will appear depending on the settings of the machine. Once you start cutting, a light will appear that shows that the cooling fan is on, although I'm not really sure why you need that since you can hear the cooling fan. Below that is another indicator that says CNC. That's an indicator you're in CNC mode for if you're cutting on a plasma table, and it only appears if you have those 2 pigtails plugged in on the back of the machine. Below that, down by the PA icon, there's a light that says OC, which stands for overcurrent. I believe that comes on when you've exceeded the duty cycle on the machine, but I actually cut all day with this machine yesterday and I never saw the light come on. So in practice, when you're cutting with a plasma cutter, you're cutting starts and stops. relatively brief cuts. So while the duty cycle's 60% and you're thinking, oh, that's only 6 minutes out of every 10 minutes, in reality that's a lot. You're very rarely going to be cutting for 6 minutes straight unless you're running a plasma table job. Lastly, there's one more icon that appears in between these two circles that indicates when the torch is actually cutting. I'm ready to make my first test cuts, and for this I've chosen some 1/4 inch material, roughly 6 millimeters, slightly bigger than that. And I'm choosing this because it's pretty middle of the road on the range, and it's also pretty typical of the kind of things that you might be cutting with this. It's used a ton in fabrication projects. So I told the company when they asked me to do this review that I wasn't going to sugarcoat anything. It was going to be a 100% honest review. And to do that, I'm not just going to make one single cut and say, oh yeah, it cuts great, this looks fantastic. I'm going to cut up this entire bar and see how the consumables last, see what the cut quality's like from beginning to end, and really put it through its paces. Likewise, I've got a bunch of 1/2 inch material that I'm going to be doing the same thing to. So enough yammering on, let's go ahead and do this. By the way, make sure wear your gloves, wear eye protection, and have a welding mask. You don't need the same kind of shielding that you do if you were arc welding or MIG welding, but you need at least a shade 5 lens when you're using a plasma cutter. By the way, I'm going to do this in real time for this first cut, and I'm going to leave my mic on so you can hear the volume of the cutter. You are using compressed air on this, so you might want to use some earplugs. I have some in as well. Alright, so I'm going to call this a skill issue. What I've got here is it didn't cut all the way through the material, and that's something they talk about in the troubleshooting guide. What I've got is a bunch of material piling up on top, and I couldn't see through the mask, but I was probably getting a bunch of sparks shooting all over the place as well. So that's an indication that I'm either I don't have enough amperage, or I'm running a little bit too fast, just dragging it too fast across the part. Alright, that still cut most of the way through, but it didn't cut all the way. Let me try turning up the air pressure a little bit and see if that helps. Now it's at 40 psi on the airflow and 35 amps. Let's see if that makes it any better. All right, that looks like a nice clean cut. I do have a lot of dross on the backside, and I think I was probably actually running a little bit slow feed rate wise. The book recommends 20 centimeters per minute, or roughly 8 inches per minute, and I think I was definitely going slower than that. This dross is actually pretty easy to chip off. So you can see that came off pretty easily. That's really stinking hot, so I'll put that down. Let's go ahead and make another cut. There was definitely a learning curve here, and I really had to dial in the pressure and amperage and get used to the feel of the torch. I started off in the recommended range on the cutting chart, but that was just a little anemic for this material. Also, I think in these initial cuts, I was probably pressing down too hard on the cut guide, and that made dragging it across the material difficult. You can see both of these things if you look at the sparks coming out of the bottom. When I'm traveling too quickly compared to the amperage and pressure settings, the sparks will skew off at an angle. This isn't super visible when you're cutting, but once you get used to the torch, you can pay more attention to it. There's a subtle change to the sound of the cut when it happens as well. You still have the hiss of the compressed air, but the tone of it changes slightly. As far as the downward pressure on the cut guide, you just need to lightly lay the guide on the workpiece and drag it. Pressing down too hard causes it to hang up on the steel, then it would jump when it released. Occasionally, you see it not cut all the way through when it jumps, and that is visible when you're cutting because the sparks are redirected upwards and the molten metal is redeposited on the top of the cut. Let's take another look at the first cut I made and you can really see this. I never was very good at staying in the lines. Always sign your work, kids. Okay, so here's the very beginning of our cut, and this is where it didn't cut all the way through. And I made, 15 or so cuts along here. I changed several times in between here. Starting right around here, I started messing with the pressure and the amperage. And I found my best results down here. Let's see, I was at 45 amps and 50 psi on the pressure. When I started doing freehand cuts, it kind of slowed down a little bit and pulled up a bit in the curves. And I think that's because as I'm dragging it along, it's slowing down and speeding up as I'm going through the feed. Next, I decided to push the limits and cut some 3/4 inch or 19 millimeter thick stock, which is well outside the range of the plasma cutter, but it handled it quite well. I was maxed out on amperage and pressure and had to slow way down on my feed rate, but it still cut through pretty easily and produced a surprisingly clean cut. I also started paying more attention to the angle of the torch while I was cutting, especially at the beginning and end of the cuts. The start of the cut isn't too hard to get going, but it needs a little extra time and a slightly outward angle to make sure you don't leave a little material behind. Once I started feeding, I found I needed to lead the cut a little by angling the torch in the direction of travel. This minimized the drag at the bottom of the cut. At the end of the cut, I definitely needed to increase that angle, otherwise the torch would stop once it lost continuity and would leave a sizable tab of metal at the end of the cut. My friend Kenton decided we should try piercing through the 3/4 inch plate as well. It took a while and it really didn't like it, but he was able to pierce all the way through and then continue on with a freehand cut from there. I wouldn't recommend doing this though, because it threw a lot of slag back at the consumables. I also pushed the limits of the range on the low end and tried my hand at a little freehand artistic work. This is out of 1/8 inch or 3 millimeter stock, which seems to be pretty typical on the decorative plasma cut pieces that I see at flea markets and craft fairs, maybe a bit thicker. I was cutting at 20 amps and 35 psi, and it cut through very easily. I will say the cut guide got in the way a little bit here. It made it difficult to see the, quite frankly, beautiful drawing of a chicken I made, and it would hang up on the dross at the top of the cut. These are pretty minor gripes though, and I quickly learned how to adapt. The thinnest material I cut was 30 gauge sheet steel, which is around 12/1000ths of an inch or 0.3 millimeters thick. This was way outside the range on the chart, and the torch was really just too hot for something this thin, even at the lowest amperage. It cut through just fine, and the arc never went out, but there was just a melted globular edge left over. It did great in stainless steel. We started with this piece of 1/4" stainless at 45 amps and 50 psi, and it went through with no problems at all. Cuts on stainless aren't super clean when cutting with shop air. They tend to look burnt and are quite rough. The dross also does not chip off like it does with mild steel, so you need to spend some quality time with a grinder. This is just a property of the material though. I know on the plasma table we have at work, we'll use nitrogen when cutting stainless, and that results in a nice smooth cut similar to what you see on mild steel with shop air. I don't have a nitrogen bottle sitting around though, so I can't test that. We also tried cutting 16 gauge stainless, and for this we tried out the 110 volt pigtail that came with the machine. This didn't work out so well. We started these cuts at 20 amps and it cut for about 17 seconds before tripping the breaker. After I reset it, it tripped again after about 22 seconds. Even after lowering it down to 15 amps, it still tripped the breaker, so unfortunately we weren't able to test it all the way up to 35 amps using the 110 volt pigtail. That said, I have not had the chance to rewire my shop yet, and the electrical work throughout it is sketchy at best. The breaker could easily be the issue here, so I probably need to do some further testing. Once I switched it back to 220 volts, I was able to cut continuously with no issues. I tested the mesh setting on the machine on some 1/8" thick expanded metal, and it works just as advertised. I cut this at 20 amps and 35 psi just like I did with the solid 1/8" material. What you're seeing here are not individual cuts. I'm leaving the trigger down and it restarts after passing over the voids in the metal. I don't work with expanded metal very often, but for those of you who do, I think you'll like this feature. Next up was some 3/8 or 10mm thick aluminum, which I cut at 40 amps and 50 psi. I believe this is 6061, but I'm not entirely sure of the alloy. Just like stainless, aluminum tends to have a rough surface finish to the sides of the cut. I think this is because it acts like its own heat sink, carrying heat away from the cut and then freezing the melted metal back onto the cut in little globs. It cut very easily on straight cuts, but when I tried to pierce through it, it didn't work so well. Looking back at the footage, I should have tried to angle the torch more to start the pierce so it would blow the material to the side. Instead, it just blew it straight up all over the consumables and actually burned through my cut guide as well. A fair amount of it sprayed all over my gloves too, so let that be a lesson to you about the importance of wearing your PPE. After changing to new consumables and setting the machine to 50 amps and 55 psi, I finished up by cutting some 1/2" or 13mm mild steel. I saved this for last because it's near the top end of the capacity of this plasma cutter and I have a lot of it to cut, so it's going to be a great test for a lot of things. I'm starting out cutting some 3" or 75mm squares to use as leveling pads for my lathes. The dingleberry on my cut guide was hanging up on my speed square and making it hard to feed consistently, so I had to turn that around. Other than that, it was a great cut. The dross on the underside tends to stick the parts together, but as you can see, they break off easily. I cut a total of 18 of these squares at as fast a rate as I could to try to exceed the duty cycle. That didn't happen with these, but I did discover something about the 4T mode that makes the trigger into a toggle switch. I had some trouble getting the arc to strike reliably while using it, and after a bit of troubleshooting, I figured out you have to hold the trigger down long enough for the arc to become established, otherwise it just goes out. I mistook that for the duty cycle being reached because I had been trying to push that limit, but it was just a coincidence. I did manage to hit the duty cycle though, with some long cuts in the same material. I made one straight cut that was 3 feet or a bit less than a meter long, then went right into another cut where I zigzagged through the material to increase the cut length. I made it almost all the way through the second cut when it finally shut off, and yes, the overcurrent light did come on along with an error code. Looking back at the footage, it was running for 4.5 minutes on the first cut and then another 4 minutes on the second, with less than a minute between them to reset. That's definitely outperforming the stated duty cycle. The overcurrent error cleared itself after about 3 minutes, at which point the amperage setting returned on the display and air started flowing through the torch just like when it's purging. I'm not sure if it was trying to strike an arc or not since it wasn't touching metal at the time, but it blasted for about 10 seconds, which is what the post time was set to, so I think it was probably that. By the way, when you turn the machine off, the settings all persist when you turn it back on, so you don't have to worry about having to reset them. You can see the amperage, pressure, and post time settings, and that it's currently in 4T mode from my last cut. Now when I turn it off, wait a bit, and turn it back on, the display will blink for a few seconds, but everything returns to normal after a short while. A set of consumables containing one cut guide, one shield, one swirl ring, and 10 each of the nozzles and electrodes costs $45.99 US as of the recording of this video. That's about twice as much as the consumables for their other plasma cutter models, which do not fit this machine, but that's still less than $5 for each pair of nozzles and electrodes. That is dirt cheap. I did bugger up the tip guide a little bit when I was trying to pierce aluminum, and that also sent a lot of molten metal straight back at the consumables, which deposited on this ceramic around the shield and chipped a little bit of it off. These are actually the nozzle and electrode that I used when I was trying to pierce aluminum. The electrode's still in good shape and is definitely usable, but the nozzle got a lot of blowback and the orifice is quite eroded, so I think this one's pretty much roached. These are actually the nozzle and electrode that came installed on the torch when I took it out of the box. So this is our 0.9mm nozzle, and the other two are 0.8s. There's only 0.004 of an inch difference between 0.8 and 0.9mm, so I'm not really sure what the point is. The consumable kits contain all 0.8mm. Anyway, these are actually in okay shape. I think if I touched this up with a little bit of Scotch-Brite, it would still cut quite a bit. The last set I installed is still in great shape, even after cutting about 10 feet or 3.2 meters of half-inch material at max amperage and pressure. I can still get a lot of cuts out of these. That brings us to air consumption. The manual recommends a compressor that can run at 90 psi and a flow rate of 250 liters per minute, which is a bit less than 9 cubic feet per minute. The cutter itself regulates no higher than 65 psi. I have a 22-gallon Harbor Freight compressor that didn't have to run that often to keep up with the cuts. I'm not sure how the size of compressors is expressed outside the US, but if it's in equivalent units, there are just under 4 liters per gallon, 3.78 in fact. So that would put my compressor somewhere in the neighborhood of 83 liters. It's not tiny, but it's not that big either. That's the story of my life, really. All jokes aside, a smaller compressor is going to have to run more to supply the air the plasma cutter needs, but you don't need a huge industrial compressor to get good performance out of it. Here we are back at temporary work surface number 16, and these are all samples of everything that I cut. As you can see, I covered the whole range of the machine and then some. We have plenty of samples here in different thicknesses and materials, from thick to thin, mild steel, stainless, and aluminum. All told, my friends and I cut for about 8 hours with this machine, and I feel like we really put it through its paces. I have to say, I am honestly impressed with this plasma cutter. It did everything that it was spec'd to do, and way more. I threw whatever I had at it to try and make it fail, and it held up quite well. The only issues I did have with it can be more than adequately explained by my stupidity, such as trying to pierce through that nice thick piece of aluminum, and not fully understanding how the 4T mode worked. This is a great little plasma cutter at an even better price point, which at the time of this recording is $399.99 US. If you're interested in picking up one of these units for yourself, I have a link to it down in the description, as well as a link to the consumables kit. While you're down there, hit those like and subscribe buttons if you think I've earned it, and leave any questions you might have about the machine down in the comments. I'll do my best to answer them. Thanks for watching. I'll see you in the next video.